Jesme, who is the administrator of the Red Lake Watershed District. So with that, I will turn it over to him here to start the presentation.
Sure. Thanks, Tony. So as you probably are aware, the Red Lake Watershed District is located in northwestern Minnesota. We encompass just under 6,000 square miles. We have various sub-watersheds in our watershed district, our Huck 8s, which we probably we will have about 4 one watershed, one plans that we'll be working on. But the project we're talking about today is in the Black River watershed. The project is located south and west of Thief River Falls, or north and west of Red Lake Falls. The project encompasses about 16 square miles. I'll go back to that one just a little bit. And it contains various diversion channels to make sure that the water gets into the impoundment that we constructed. As you can see, there's yellow lines. They're all the diversion channels that were constructed as part of the project, and the red rectangle shown in section 3 in this area here is the actual impoundment of the project. This project did start with the Red River Basin Commission's long-term flood solution study that went on quite a few years ago. And Black River was one of the projects that was defined in our strategic plan. We looked at the projects. There was four alternatives that were looked at. And we selected the project that we did pick, simply stated because there was very good landowner cooperation, and ultimately it was the best site for the storage given the topography. The Watershed District appointed Houston Engineering to proceed with the project and also assist with the alternatives, and the Red Lake Watershed District proceeded to purchase the land and/or flowage easements for the impoundment back in 2017. So this project, again, is located in a 16 square mile drainage area. The black line is the benefited area, so to speak. If you're looking at a legal drainage system, you would look at a benefited area, and this project is no different. We did set up a water management district for this project, we will get into later. But this black line is the water management district boundary and/or the drainage area. The 3 diversion channels that I mentioned earlier were constructed as part of the project to divert the waters from this watershed into the impoundment. The landscape is such that it's a 45-foot elevation drop from the arrow in section 21 that's showing the black line, and it's a 45-foot drop to JD 25-3, which is also the Black River proper. It's a legal drainage system within the Black River channel. So we constructed a diversion channel along the Highway 12, we call it, to divert waters into the system. We also, to divert the waters in from this drainage area, we diverted south to the same location. And we also diverted waters that used to go west, and then it went south and left this watershed. And we made sure this all water was contained and brought into the impoundment. There's also a situation where there was a lateral to Judicial Ditch 25-3, which was under jurisdiction of Pennington County Drainage Authority. This project was JD 25-3, started up in this reach, continued all the way to the Black River. So parts of this project was to not only improve parts of JD 25-3, but also abandon part of this system. That was all done through Pennington County Drainage Authority. Once this project was completed or moved forward, then the Pennington County Drainage Authority transferred the legal drainage system to the Watershed District to help maintain this system along with these other laterals that were constructed as part of the project. So from now on, all these laterals will be maintained through the water management district fee, which is similar to what a benefited area is for a legal drainage system. With that, I'm going to let Tony start talking about more of the design of the project or oh, I guess I do have one more item. I'm going to go back to this just to mention the outlet. So once we get the impoundment constructed, all the water gets stored in the impoundment. We also have a operational gate that will then transport the water to the Black River proper. The legal drainage system ends somewhere up in here, JD 25-3, and then this turns into just the Black River proper. So the outlet of the impoundment is in this location and outlets into the river. So the water management district. So what the watershed district had to do, as with all plans, prior to forming a water management district, you have to have a water management district and all the fees associated with it in your plan. So we had just finished our Red Lake River One Watershed One plan. We're one of the 5 pilot projects when the whole Watershed One plan got started. So we had to revise or amend our plan to include this water management district. And as you can see on this map, it shows various service areas, we call it, for the water management district, and they're all associated with fees. So you look at all the template here, but each area has a different rate, similar to what a benefited area map would show for a legal drainage system. The Black River impoundment and the project was funded through various sources: the Red Lake Watershed District, the State of Minnesota Flood Damage Reduction Program, and the Red River Watershed Management Board. That was how the project was initially funded. Things had changed, and since the One Watershed One plan was developed and funding became available, there was also some water quality components of this project that were funded through MPCA 319 grant, and I think we go on to that later on in this presentation. Breaks down all the costs associated with the project. The Red Lake Watershed District proposed the water management district charges for long-term operation and maintenance, only the diversion channels. The Watershed District Board, through our capital project funding, will maintain and manage the impoundment part of the project, but the landowners through the water management district fee will be maintaining all the diversion ditches, no different than a legal drainage system for the future. And with the water management district, you have to have a maximum annual operation and cost associated with your water management district fee. And through various discussions and looking at the history of operations from previous legal drainage systems, we pretty much come up with a cost that would be very fair and something that we feel we can manage the systems in the future. And that is to not exceed $75,000 in maintenance costs throughout all these diversion channels. So we feel with that $75,000 per year maximum, we should be able to operate and maintain these diversion channels pretty adequately. So this is just basically how we went into the service areas, and each area has a different cost associated with it. And it was all formula driven. So when you do your water management district amendment to your plan or incorporate into your plan, you'll have to give some thought as to how you come up with your funding mechanisms. And there's various ways to do it. I'm not going to get into the weeds of how we did it, but it will, if you had any questions in the future on how we came up with it, we can surely answer that for you. This is just an example of what the maximums would be based on the $75,000 and what we see basically on an annual basis of $10,000 to maintain upwards of 16 miles of channel. So, and I'll just let you look at them here. I'm not going to go through them all, but it's quite small. What your benefits would be or what your costs would be for a landowner, just from the maintenance standpoint. We don't anticipate a lot of work being done on these diversion channels. for, quite a few years, as is typical with any new system or improved system. Now I'll turn it over to Tony, and he can discuss some of the inner parts of the project as it was designed.
All right, thanks, Myron. So I'll talk about some of the design aspects of the project here. First thing I'll talk about is the impoundment site itself, the embankment. This is a site map zoomed in to the embankment site itself. It covers roughly about a section and a quarter or so here. Just showing you here, this is our north inlet coming into the impoundment site. This is a 14-foot by 7-foot box culvert that goes through CASA 3 up here and feeds into the impoundment site. In blue, we have internal drainage ditches that bring the water down to our southwest corner where that principal spillway riser structure is located, and I'll get into some of the detail of that here as well. We also have a 103-inch arch metal pipe here through the county gravel road here as well, bringing some of that water from the east, as Myron was showing you in previous slides, into the impoundment site through internal ditching here as well. We also had impoundments, and I'll show you some photos of those as we get into the construction aspects of things, but impoundment sites here that did change some of our internal drainage here to where we just tied in these inlet ditches into those impoundments, and instead of having a continuous inlet ditch on the inside of the impoundment site. We also have an earthen emergency or auxiliary spillway, 500 feet long here on the southeast corner of the impoundment site, with emergency spillway ditch also constructed along the southern boundaries here of the impoundment site. And then in black here just outlines the kind of the center line of the impoundment itself. The embankment, just to chat here a little bit about the design of this. Top embankment is a static elevation from west all the way east along both the north and south sides. At the 1023.5 is the design height. In this cross section, you can see here there is a dash line here for an overbuild. The reasoning for the overbuild is due to a potential future settlement of the levee, and that did vary from kind of the western edges where our levee is the highest to kind of the eastern edges along the north and south side where that settlement is projected to be a lot less. We also have an interior or the wet side of the levee slope is at a 5-to-1 approximately, and then the external side is at a 4-to-1. We did strip about 18 inches of topsoil off kind of the footprint of the levee itself, and then also did what we called subgrade preparation, which was kind of within the core 50 feet of the center of the levee, where on the western edges where our levee heights were higher, this excavation was up to the range of about 3 feet in depth, to where further to the east, where our levee was tying back into natural ground, it was closer to about a foot. And really the reasoning for that subgrade preparation was for the potential of differential settlement in the levee system, which was a concern when we did our geotech reporting and work early on during design. As I mentioned, there are two spillway structures. The principal spillway structure, the primary spillway structure, is shown here below, kind of a schematic showing that. The other one was that earthen 500-foot auxiliary spillway that I showed on the previous slide on the eastern edge. But just kind of give you an idea how this works and operates. So this is the wet side of the levee here. This is the dry side on this side where I'm pointing here with the mouse. We have the ability to have gated storage within the site up to this elevation 1019. So this is a riser tower structure. Internal dimensions are 15 feet wide by 9 feet wide. We have a sluice gate attached here and then also a 60-inch reinforced concrete pipe that feeds the water from in the impoundment through the structure here, and then the outlet as well as a 60-inch pipe that outlets into our outlet channel and then eventually into the Black River. So if we have this sluice gate shut, we have the ability then for water to build within the impoundment site up to this 1019 elevation before water then would start spilling over our principal spillway riser structure. So at that point, at that 1019, we have just shy of 3,200 acre feet of gated storage, which equates to about 3.5 inches of runoff over that entire 16 square mile drainage area, as Myron mentioned earlier. So that's runoff, not rainfall. So actual true runoff coming off the landscape of 3.5 inches. So some pretty substantial ability to store water here. We also have an additional about 900 acre feet of storage. Now that would be ungated, so that would be water then above 1019 that would be flowing, potentially through the riser and out the 60-inch pipe. But really that 1020.5 is up to that auxiliary spillway height. So we got about 1.5 foot difference in height between our riser tower where water starts entering and then where that emergency spillway or auxiliary spillway elevation is. And then we have an additional 3 feet of freeboard on the levee itself above that emergency spillway elevation. So in total, up to that emergency spillway elevation, we have just over about 4,000 acre feet of storage where we can meter that flow either through gated storage completely or metering it through the riser tower. Our diversion ditches and outlet channel was also sized very similar, but this is a schematic kind of showing the layout of those diversion ditches coming in. They're all designed for a 10-year ditch design, which really means we can have water. Water would be roughly just below kind of the adjacent natural ground elevation in that 10-year frequency event. So water would not be sitting on the landscapes adjacent or the farm fields adjacent to that. Now, once we get a event that would be higher than a 10-year type frequency, water would probably still be within the spoil bank that's shown here in the road on the other side. But water through side inlet pipes or just water sitting on the landscape probably won't be able to feed in here until that water level goes down within the ditch, and then all your adjacent drainage can then come in and make its way to the Black River impoundment.
Tony, do you want to explain why a 10-year design?
So the 10-year design is kind of a standard through the basin, through the mediation agreement. Documents, technical papers through different entities that have put documents for design methods together. Not saying that all cases a 10-year design is put into play, especially like in ditch systems and things like that. It kind of more comes down to what the benefited landowners want to do there and what they can afford. But in project instances like this, the 10-year design is a pretty common design approach and economically feasible way to get that water then into that impoundment site. Just to kind of explain a little bit more on this slide. So there was an existing right of way that the county had for the county road ditches that did exist before this project was developed. But now with this project in place, we do have an easement that will go permanent easement out to about 16.5 feet, at least at a minimum, from kind of the top of our spoil bank. Our spoil bank does have a profile set for it. Most places it was roughly about six inches to a foot lower than the adjacent road, and that was just for if we do ever get those higher events that water would spill out into the fields than over the roads and causing issues heading westerly. where the topography wants to take the water. And then this would all then be grassed. We'd have a grass buffer from here on to the right on the photo. And then our temporary easement shown out here is more or less just for construction purposes, for placing spoil, shaping spoil. We have a real gradual back slope on that spoil. And then for stockpiling topsoil during construction. So all this area here will really be farmed again by the landowners with those gradual slopes once the project here is completed. So how does the impoundment site function? How much water can it hold? Put it into perspective. So if we pick on the 100-year event, so we modeled 3 different scenarios, 3 different durations: the 24-hour, the 4-day, and the 10-day durations for the range of these synthetic events. And I guess if we just pick on the 100-year event for all those durations, really those rainfalls vary from about 6 inches up to just shy of 9 inches of rainfall for those differing events. And I guess what I'd like to take away from this slide is if the impoundment is in a dry state or an empty condition, which is how the district wants to operate these things, and we have this event, we can really hold that entire 100-year storm without releasing any water out of the site if we have that gate closed and the impoundment is in a dry state. So how does that look on the landscape of the impoundment itself? These different shadings are just those different synthetic events from a 5-year up to a 100-year 24-hour event, with the red actually showing the riser, that 1019 I was talking about earlier, just showing how that relates on the landscape from a contour standpoint. So really all I'm trying to show here is that 100-year 24-hour elevation, roughly about our peak elevation in the pool is 1017.7. And we have about 1.3 feet still of freeboard, I guess you could call it, before water would start spilling over that riser tower and going out our outlet channel and into the Black River. So by holding that water, what does that mean downstream for benefit purposes? So if we look at where our outlet channel is entering back into the Black River itself, and if we pick on those 100-year events again for these different durations across the table, we are looking at about a 24% peak flow reduction in the Black River itself at this location. If we move down, further downstream, at the confluence where the Black River actually enters the Red Lake River west of the city of Red Lake Falls, here we're looking, if we pick up that 100-year event again for those different durations, we're anywhere from about 5 to 7% in peak flow reduction where it's entering into the Red Lake River. So pretty substantial reduction factors from one project for this area. And with that, I'll turn it back over to Myron here. He'll talk some about permitting and some of the funding and cost aspects of the project.
So as with all projects, there's a lot of permits and applications that have to be had. As you can see, it is a high hazard dam. So we did have to have a dam safety permit from the DNR. We also needed a U.S. Army Corps of Engineers permit, which basically we ultimately received the nationwide permit. We also had an MPCA permit, Pennington County Shoreland permit, Pennington County Highway Department for work within their county road right-of-ways, and then also your stormwater pollution prevention plan. The total probable cost of this project was $8.8 million. We purchased 477 acres of land. We purchased 249 acres of flowage easement from one landowner that decided he wanted to keep his land and keep it into private ownership. Because with all our watershed district projects, if we buy the land and we have a project, we open up the public hunting. This landowner really recognizes that, and their family hunts various impoundment projects that we already have. and they understand the value of keeping the land in private ownership. So this landowner chose to take less money for just a flowage easement so they could have it for hunting purposes if farming didn't work out. We also had 87 acres of permanent right-of-way, 76 acres of temporary right-of-way, and I'll just look at the project cost broke down here. Thus totaling $8.8 million. How it was funded. So again, we had to go, we had to go to the Red River Watershed Management Board, which is a huge funding partner for these types of projects. And they agreed to pay 67% of the probable cost. I should step back a little bit. We applied various times for state funding through the Flood Hazard Mitigation Grant Program. With the lack of funding that our legislators have appropriated to that funding mechanism through the state, we were not given any money from the flood damage reduction or from the flood hazard mitigation grants of the state of Minnesota. So that was a little discouraging. It took us 3 years to try and get funding together for this project without state funded or without state assistance. So at the end of the day, the Red River Watershed Management Board and the Watershed District decided to move on with this project without any state contribution whatsoever. So with that, the Red Board approved 67% of the project funding. The Watershed District, through our capital project fund, appropriated $2.9 million for the project. Well, then as we started moving through various components of the project, we looked at other types of funding that could help with water quality portion of the project. With that, the Red River Watershed Management Board also puts a part of their funding into water quality based funding. So with that, the Red River Watershed Management Board gave an additional $78,000 for some water quality components to the project. We also applied for a MPCA 319 grant, which we got for the Red Lake River sub-watershed, which this project is located. So we earmarked $56,000 from the 319 grant. We also had the One Watershed, One Plan, which at a minimum, we're going to get $64,000 from the Red Lake River One Watershed, One Plan. That number is going to be closer to 95 to 100,000 when the dust settles. But that was one of the funding mechanisms that we used as well. And then the Red River Basin Flood Damage Reduction Work Group, which assists in giving funding for projects to get them on the ground for pre-engineering and such to get basically get some of your engineering done and your earlier scopes completed. They gave a total of $72,000. And then, like we said earlier, the Water Management District, which is Water Management District funds that were established through our hearing process, will pay for all the future maintenance on the diversion ditches. And I should state that this project is very unique, where that in the past you have flood damage reduction projects, and what that does is it allows landowners to improve their drainage upstream without causing adverse effects downstream. This project, because of the sheer nature of the project that we had to divert waters, landowners also got their diversion ditches constructed at the cost of the project. So basically, I use the analogy, if someone will build me a house, I'll put shingles on it in the future. And that's really what this project did for landowners. So it really was beneficial to upstream landowners as well as downstream landowners. With that, I'll turn it over to Tony, and he can talk about some of the project construction components.
Yeah, so as we sit today, this project is pretty close to substantially being completed. The contractor on this project was RJ Zavril and Sons out of East Grand Forks. They started construction, and they had the option to start construction fall of 2020, and they had some pretty good weather to get started, so they did start, and it went real well. In 2020 they were able to complete the levee, complete levee construction, the outlet structure, for the vast majority of that principal outlet structure and the outlet channel, all in the fall of 2020, over about a just shy of 2-month period.
To equate that into dollars, Zavros did about $2.3 million from October 22nd to the middle of December. That's how fast they came in full bore with all their equipment, and they moved a pile of dirt and did it very, very efficient in a short time frame.
Yep, as you can see kind of on this photo, they had a lot going on at one time out there. So that work was done in 2020, and then in 2021, the diversion ditches were excavated and completed. Final completion date by contract is August of 2022 on this project. I see that final completion being done quite a bit sooner than August 31st, really with some minor things to wrap up next spring, with some punch list things and different items. I'm just going to kind of show you some drone pictures of the project developing, and then also some of the things that were completed. Down here in the bottom left, I just kind of have that map to try to help show you where these pictures are located. So both of these pictures are located in the kind of the northwest corner of the impoundment site, adjacent to CASA 3, which you see here in the top picture. So here the levee is really pretty much complete. They're putting topsoil back on. This was taken in 2020, and just doing some mulching for erosion purposes along this stretch. This is looking east. This bottom picture is looking back south along the western edge of the levee here. They got all the material in place, the clay in place prior to putting topsoil here, and they're just beginning to put topsoil on. One of the other unique things here is this is just a picture of the borrow pit, if I can get my mouse to operate here. Borrow pit that was constructed, at least in this corner. In this corner, they did like an L-shape type approach. So the borrow pits on this site were really open. The contractor had the ability to kind of do as he pleased with where the locations of these borrow pits were, outside of some areas that we had marked that they couldn't use because of wetland potential impacts and things like that. But otherwise, they were kind of open to do a format how they thought they could best efficiently perform the work to be done. So in this location, they had kind of an L approach where they were able to use this borrow pit to kind of build here, and then over here they were able to, which is this same borrow pit coming off that other picture, to build this. So they kind of had one borrow pit for this whole kind of corner construction.
Explain how that's settling bonds work with the interior drainage.
Oh, I'll get to that here. So then this next photo just kind of shows construction happening at that principal spillway outlet structure. In this north picture, they have what's called a concrete cradle in place, which is what our 60-inch reinforced concrete pipe sits on. They're in the process here and pretty much have all their forms put together here for that riser tower. You can see the boom truck in this photo, and also down here, they're getting ready to pour the actual riser tower itself. They do have in those forms, you can see a 60-inch pipe that was placed, and then they cast that concrete for the riser tower right in around that 60-inch pipe. This picture, I want to say, was taken a day or two ahead of Thanksgiving in 2020 on this photo. Here is another picture from 2020 as they start construction on the outlet channel itself. In the background here is actually that principal spillway riser structure with the impoundment going that way to the east, and then to the north here along this edge. This is the Black River here itself. You can see it's late fall. We got freezing conditions as they're just beginning to start construction here. And then this is kind of that same location in later 2021 now, with the outlet structure, the outlet riprap in place. the ditch constructed, vegetation established. We do have some kind of bird bass here that did show up late in the year. We really were in pretty much a drought up in this area for a vast majority of the summer for 2021. So once we got into early fall, we did get some rain events that did happen that did kind of show some of these bird bass where we really didn't have any precipitation to show some of that happening early on. So since this drone footage has been taken, we have addressed all those bird bass with the contractor. As we move further east now we are at the outlet structure, that principal spillway outlet structure, as it is constructed now and finished. We have the outlet end here is that 60-inch reinforced concrete pipe that outlets here. The riser tower with the catwalk here, so the Watershed District staff can go up and operate the gate from up top here. As Myron was mentioning earlier about those borrow pit areas and things like that, this is the borrow pit that was used in this kind of southwest corner for building, kind of going both north and east here. As I mentioned early on, those diversion or then interior ditches, we didn't completely construct those all the way through. We just kind of connected them with the borrow pits as they come through. And really the thought behind that is to use those borrow pits as another source of settling out, for not transferring those sediments downstream and trying to just help out with water quality purposes there as well. Moving further east here, now we are at the location of that emergency spillway location. You can kind of see it here where it drops down elevation wise about 3 feet for that emergency spillway, which is about 500 feet long here. And this south diversion ditch that wraps around the Black River Church, and you can kind of see it going up off the top of the screen here. Working our way even further east on that south diversion, I just wanted to show you, this is one location where we had a lot of topography. We got multiple rock drop structures here that kind of take out some of that topography so we can maintain somewhat flat ditch bottom slopes to slow that water down as it travels west. This area was some pretty silty, sandy type material through this ridge. We had some seepage, things like that happening. That was a concern at the time, but I just wanted to kind of show you once we got it finished and vegetated, it really turned out to be a pretty nice final product here for the ditch in this portion. Moving further north now, this is that 14-foot by 7-foot box culvert through CASA 3 as it feeds into the impoundment here. The ditches here on the north side, these diversion ditches were done later here in 2021. The south diversion ditch was performed earlier on in the year, so you can see that we had good vegetation established there. To where here, these photos were taken probably a month and a half or so ago, but we do have them seeded and mulched, and there was some green stuff starting here. But definitely something we will be keeping an eye on into spring next year and looking at these things. This photo was taken at the intersection of CASA 3, looking north at the County Road 68 diversion ditch feeding in. Again, we have some more of those rock drop structures in place. The ditch is completed, seeded, mulched, and really ready. Once the grass establishes, ready for operation here. And then the last picture I'll show here for construction purposes is just north of the intersection of CASA 12, which goes north here, and then CASA 3 runs east-west. There's a box culvert here, a 12-by-5 box culvert that goes through CASA 12. Early in design, we were looking at bringing that through and feeding actually that Judicial 25 branch that has a culvert through just off the screen here. But we really had to keep the ditch for a short stretch on the west side of the road due to this tower that you can see here in place. There's some anchors that come off that tower that would have been right in the way of our ditch design. So we wanted to stay away from that. So we moved the ditch over to the west side of the road here for that short stretch. So I guess as things sit today, as I mentioned, we're pretty much substantially complete with the project. Operation wise, this project will be operated this coming spring. And just this slide kind of gives you an idea of the operation plan that is in place for this project. In the summer type situations, you know, the gate will be open more as a pass through for just kind of those smaller rainfall events. If we do get larger scale rainfall events and we are in a wet state or there's potential flooding issues downstream, the district has the option then to go out and close the gate and operate the site. And then closures and openings really are going to be based on trigger points downstream. We're going to have some local gauges that the district has on the Black River that will be used, and then also USGS gauges on the Red Lake River in Crookston and Grand Forks, and also the Red River in Oslo. And then we'll just try to feed back if there's, once conditions allow, we will feed the water back into the Black River system at a discharge roughly around a 50 CFS is what we've modeled to maintain no downstream impacts to folks. And then the maintenance portion, Myron touched on this earlier, so I probably won't dive into that, to just kind of save some time here for questions and comments. One thing I guess just to let you know here is our contact information for both Myron and myself. Houston Engineering does have some more information on our website about the Black River impoundment, and then also there is some video that both Myron and myself were involved with that is out on YouTube if folks are interested in looking at that, where we talk about the project in more detail and things like that. So if you just YouTube Black River impoundment, you should be able to get to those videos. So with that, I guess I would open it to questions. I see we do have maybe a couple.
Yeah, there's a couple of questions in that chat if you want to take a look at those.
Okay.
Or I can read them to you.
What type of storm event until water runs through the spillway? So I guess in that scenario where I was showing that 100-year event, those 100 events, if we have the gates closed and we are dry, which is the way it will be operated, so we will go into spring, you know, like spring runoffs,